A VPN, or virtual private network, creates an encrypted tunnel between two clients on a public or untrusted network. It enables clients to obtain secure, encrypted communication over insecure networks like the Internet. When clients connect to each other on the Internet without a VPN, the traffic flowing between them may easily fall prey to hackers using packet capturing software, and that organization's private information may become compromised. When a VPN is established between a client and a server, the VPN tunnel encapsulates the packets flowing between the tunnel endpoints with an extra header, and a VPN connection encrypts the data payloads of those packets. When making a VPN connection, two sets of IP addresses are used. The first set are the public IPs whereby the client connects to the server on the Internet. The second set lies within the encrypted tunnel created by the VPN and is assigned by the server via DHCP or an internal bank of addresses. There are three primary protocols used to construct VPNs in both Linux and Windows. These are SSTP, or Secure Socket Tunneling Protocol, PPTP, or Point-to-Point Tunneling Protocol, and L2TP, or Layer 2 Tunneling Protocol. The first of these, SSTP, or Secure Socket Tunneling Protocol, uses SSL, or Secure Sockets Layer, on port 443 for encryption. As such, it is compatible with and passes through most firewalls with web traffic. The next, PPTP, or Point-to-Point Tunneling Protocol, is extended from the old PPP. It uses MPPE for encryption. It is more compatible with older routers and servers. In Windows, it only supports 128-bit RC4 encryption. The last, L2TP, or Layer 2 Tunneling Protocol, is also the most sophisticated. It uses IPSec for encryption instead of MPPE, so it supports shared keys and certificates. It offers header compression for improved efficiency. And it supports stronger encryption than PPTP, such as 256-bit AES and SSS. As such, it may be less compatible than point-to-point tunneling protocol for communication with older routers and servers that don't quite understand L2TP. In addition to tunneling protocols, routing and remote access services and VPNs utilize authentication protocols. Some of the common ones are as follows. The first option is probably the most simplistic, and that's unauthenticated access, in which case no credentials are submitted at all and no encryption takes place. The next option, a bit more sophisticated, is Password Authentication Protocol, or PAP. It does not encrypt authentication or connection data. Credentials are sent, but they're sent as plain text, so it's not very safe. The next option, SPAP, or Shiva Password Authentication Protocol, uses weak encryption for authentication. It's compatible with Shiva devices, but since there's no encryption of the connection data and the authentication encryption is weak, it's recommended that you use other protocols on modern systems. The next available option is CHAP, or Challenge Handshake Authentication Protocol. This encrypts authentication data through an MD5 hash, and it's compatible with non-Microsoft clients. However, to implement this kind of authentication, passwords must be stored with reversible encryption, and if you do this, you must also reset the passwords. The next option, EAP MD5 CHAP, is Extensible Authentication Protocol with an MD5 hash, also Challenge Handshake Authentication Protocol. And combining these two, it's compatible with Leopard or Tiger Mac OS X. It does not encrypt connection data. The next two are used most frequently on Microsoft networks, and this is MSCHAP version 1 and MSCHAP version 2. Version 1 provides one-way authentication. It encrypts authentication and connection data, but uses the same key for all connections. Because of this, it supports older clients like Windows 95 and Windows 98. Version 2 provides mutual two-way authentication. It encrypts authentication and connection data, and uses a new key for each connection and each transmission direction. However, because of this, it's only compatible with 2000 Server XP and above. Finally, there's Extensible Authentication Protocol. It's certificate-based, used with smart cards, encrypts authentication and connection data, and it's not supported on standalone servers. That is, they must be a domain member or a domain controller, part of Active Directory. Let's set up the VPN server. We're going to implement another configuration of routing and remote access. And this is a VPN and NAT server. And I want to right click and say configure and enable routing and remote access, and follow the wizard and check virtual private network access and NAT. Remember that a NAT server performs network address translation, so it takes one public IP and shares it out among multiple private IPs. So it's important which interface you select. In this case, I've renamed them. So my private network is local static IP, and my public address is dynamic IP. And I want to make sure I select this interface because it's going to implement firewall and security settings that you don't want to implement on the private local area connection. So make sure you select the right interface. And I'm going to click Next. And how do you want IP addresses to be assigned to remote clients? You could choose a DHCP server if you have one set up and just configure a scope accordingly. This is a standalone, and I'm not running DHCP, so I'm going to choose from a specified range of addresses. And I just need to give it a scope, right? So a bank of, say, maybe 20 dial-in addresses. And it doesn't have to be the same as the subnet that you're on. The tunnel endpoints inside of a VPN have their own set of IPs that will be assigned dynamically here from this scope or this address range, and then the external IPs, that is the IP you get from your internet service provider, and the IP address, the public address of the server on the internet, are two totally different IPs. So there's really 4 IPs involved in a VPN connection, 2 internally that are encrypted and 2 externally that are not. And I'm just going to do 200, 100, 120, 200, 100, 140. Okay, so bank of 21 there. And I'll click Next, and notice it says, do you want to set up the server to work with a RRAS server? And the default is no. It's going to be sort of a standalone server with its own set of remote access policies. However, let's say that you had multiple remote access servers in your organization. If you did, you could set up what's called a RRAS server, and basically that RRAS server would centralize the authentication policies and remote access policies for all of your VPN and dial-in servers. So it works sort of like maybe group policy on domain controllers, in the sense that you'd be able to centralize your policies and your permissions and security requirements. So I'm going to go with this one. Again, I'm not setting up a RRAS server. It's just a standalone VPN server, and I'm going to click Next and Finish. And Routing and Remote Access has created a default connection request policy called Microsoft Routing and Remote Access Service Policy, and it works with the network policy server. And that's because, again, I haven't set anything else up, or I don't have anything else set up on this machine yet. So I'll say OK to go with the default, and then OK, and it'll restart the Routing and Remote Access service. And when it does, notice the arrow goes from red to green. And now look at the things that I have available. Under IP version 4, as far as NAT and IGMP and DHCP relay agent, and then look at the things I have available here as well. In this case, for remote access and remote access clients, I have ports that are installed, and SSTP, and there's PPTP, point-to-point tunneling protocol with MPPE for encryption. There's L2TP with IPSec, layer 2 tunneling protocol. All of these different options are different ports. These are, virtual ports over which people could connect to my VPN server. And if they did, then these would become active, and I'd be able to view their status. And we'll go configure the client in a moment, and we'll come back here and take a look at these and see how you can kind of look at your connections and see what's going on there. I have no remote access clients dialed in. This will change when I do. And remote access and logging policies, and this would launch NPS. Okay. And I'll go ahead and just take a gander at that. So our network policy server, there are 2 default network policies: connections to Microsoft Routing and Remote Access Server, and connections to other access servers. And by default, they are enabled, and notice that by default they're denying access. And that's just sort of a security precaution. You would kind of want to really limit who you give access to, your network via VPNs and via routing and remote access. But I could enable that policy and take advantage of that policy. Connections to other access servers, again, by default as a security precaution, it's those connections are denied. Both of these are enabled. I could disable them if I didn't want them to apply. Okay, and notice that's disabled there. I'll stretch out that little column. And then I'm going to go ahead and re-enable it. So just some of the settings and features under Network Policy Server, or NPS. And this is my NAT here. And notice it's added both of my interfaces. And I can even tell that this is the interface under which I'm implementing network address translation. So my single public IP that I'm sharing out among multiple private IPs through this interface. Let's look at some of those VPN server features. At this point, we're ready to configure and set up the VPN client, but before we do, let's go over some of the VPN server features, as well as NAT, that were configured when we implemented this version of routing and remote access. Notice both my network interfaces are here under Network Interfaces. Once we dial in and we start getting remote access clients, they will appear here and we can manage them accordingly. Ports appear here and I can manage them here. Here's Secure Socket Tunneling Protocol. Down here is PPTP point-to-point tunneling protocol with MPPE encryption. Down here is Layer 2 tunneling protocol, or LTTP, with IPSec encryption. Here I can define my remote access policies and logging, and we can launch MPS, the Network Policy Server. If I want to do that, go ahead and launch it here. And remember, previously we had enabled or allowed access here. It was, by default it's set to deny access, and that's a security precaution. It's a potentially dangerous thing to let people, on the internet VPN into your company's private network. So, that's the reason those are denied or shut down by default. But we granted access on these policies. And also I could enable or disable them. We talked about that. What we didn't do, what if we wanted to create a completely new remote access policy? And you can have multiple policies and they can combine. And if I wanted to, let's say that I wanted to add a group here. Let me look for domain users here. And that's a built-in group. And I would not want to, in reality, I would never want to use domain users, because that's like any authenticated user in Active Directory. I wouldn't want to let just anybody VPN into our company's private network. So I'd probably create a restricted group. I might make a group and call that group VPN users and restrict it to just a few certain people that I would give accounts and passwords to that would be allowed to VPN in. But just as an example, I could click Next, and then notice access granted or denied for that group. So I could explicitly deny access to the VPN server. In this case, I'm explicitly granting it. And then here's other options I can utilize. Authentication types, extensible authentication protocol for smart cards and MSCHAP. Look at all the authentication options down here. I could do, PAP and SPAP for unencrypted authentication, just sort of plain password authentication there. And then I can encrypt with CHAP, MSCHAP version 2. If it's older clients, you want to stick with like 95 and 98, or if you're utilizing that, you'd want to use MSCHAP. Otherwise, if it's more modern clients, you want to utilize MSCHAP version 2. And I could go through and idle timeout. I could specify maximum time of minutes that the server can remain idle before the connection is disconnected. And the reason you might specify that is, if let's say somebody logs in and then they forget that they're logged in, and they stay logged in all day, they're kind of wasting a potential connection. You only have so many ports. You have quite a few there, but it's limited. It's not endless. Well, that would keep them from consuming or using up that connection when they don't need it. It would force them to disconnect. And then the session timeout, specify the maximum amount of time in minutes that a user can be connected. And that's if we wanted to put limits on their connection there. And I want to go ahead and uncheck both of this. Called station ID, allow access only to this number. And if I were to select this option, specify the phone number of the network access server, and I could type that number there. And that just gives me, further restrictions or further security that I can implement. Allow access only on these days at this time, or these times, and I could, choose different times here if I wanted to. And go ahead and uncheck that option. And then the NAS port type. And notice the different options here. I could use ISDN, asynchronous modem, VPN, just different port settings and things I could configure. And in addition to those settings, I could do multi-link. If everybody today is on broadband. Not too many people are using POTS or plan on telephone service, but if you were, you could link multiple modems together if you had a modem bank, and you could get that some aggregate total of bandwidth of all those modems that you had linked together. I could implement IP filters, and then encryption settings and IP settings. And then I'll click next, and then I would click finish. And there would be my route policy. And I'm not going to use that, I'm using the default, but I just wanted to go through some of these features. And finally, going down here under IP version 4, let's look at the relay agent. And a relay agent, if I wanted to, I could add my other interfaces as well. But why, when we set up the VPN, did it add the internal? And it's using that. Remember that there's 4 IPs involved. There's 2 unencrypted, the one given you by your ISP and the public IP address of the VPN server you dial into. And then there are 2 internal encrypted IPs inside the VPN tunnel. And those are assigned by that bank that we set up, those 21 available IPs that we configured in the wizard. And this sort of acts to relay those IP addresses. In addition, if I were using routing and remote access and I wanted to add either one of these interfaces, let's say that I were on a subnet where I didn't have a DHCP server. And remember that subnets, there are broadcast domains, so routers limit broadcast traffic on those subnets by default. If I wanted to avoid having to set up a DHCP server on each and every single subnet, then I could configure a relay agent. And a relay agent would simply listen for the DHCP discover broadcast and that 4-step handshake, and it would relay it through the router across to the next subnet, wherever there might be a DHCP server. And it would hear that, and it would respond with a DHCP offer, and the client makes a DHCP request, and then the server responds back with a DHCP acknowledge. But the relay agent itself would be, act as the middleman, getting those packets to and fro across the router or between broadcast domains without allowing other unnecessary broadcast traffic through. So that's kind of a neat feature, a neat service, but in particular we're using it with our VPN server. Internet Group Management Protocol, and I have to add both my interfaces here. And finally, network address translation, and again, that's to allow multiple connections over a public IP, in this case VPN connections, and if I wanted to share out internet access and things. Notice that on my public IP, NAT has been set up here, along with address pool and service and port options, and notice that my static IP has been set up here. Didn't really have to get into all that to set up a VPN server, but I thought it would be worthwhile going through the different, some of the different features and bells and whistles and things involved with a VPN and NAT server. So now let's go configure the client. Now I need to create remote access user accounts and enable them to dial into the VPN server. Now I need to configure a group and accounts and Active Directory users and computers that has permission to dial in and connect remotely. And I'm going to go to users, and I'm just going to make a couple of users here. Remote 1, and I'll call him Remote 1. And I'm going to make another user. Let's do Remote 2. And let me set this and set this. Okay, so I have 2 remote users, and I'm going to make a group. I'm just going to call it remote users, and of course it'll be global security. As members, let me add remote 1 and remote 2. Okay. And then on each of these individual users, I would go here, and if I want to enable access, I could control access to, again, network policy server, but I'm going to allow network access. And then notice some of the other options here. Verify caller ID, and that would be if I wanted to, see what number they were calling from. And then if I were going to call back, I could say set by caller, and I could also always call back to a specific number. So I could set it up so they could only dial into the VPN server from a specific phone number. So several different options there that I could allow or implement on my network access and my dial-in access to improve security. Right now I'm just going to check allow access. And same thing for remote user 2. I'm going to go to dial-in. I'm going to say allow access. Now that we've set up the VPN server, let's configure the VPN client. I want to go to Control Panel, Network and Internet, Network and Sharing Center, and here I want to select Set up a new connection or network, and I'm interested in a VPN connection, so I'll click. I want to say Connect to a workplace, and that is set up a dial-up or VPN connection to your workplace. I'm going to select that option and click Next. If I had POTS, a plain old telephone system, I could connect using this option. But if I'm connecting over broadband, which is probably the option you'll need, you'd choose this option. This would be the public IP address. So your organization or company's server, you could find it out through your internet service provider or do a trace route. But this would be their public IP address on the internet. And it's probably a Class A address, but for me that's 220.1.1.1 in this example. And now here I would just specify the name of the connection. So I'm just going to say VPN to Galactica. We look at several of the options here. There's use a smart card if you're using extensible authentication protocol. And you could allow other people to use this connection if it was not just you. And this option here, don't connect now, just set up the icon so I can connect later. That option would be utilized, let's say that you're an IT person and you're configuring a fleet of new laptops for your sales force. And when they go out on the road, you want them to be able to dial home and get into the company's private network over VPN. You can set up a bunch of connections without having to actually go through and connect and, go through the process of authentication there. So that might be a useful option. For now, we're going to go with all the defaults and leave those unticked or unchecked. I'm going to click Next. The username, I'm going to say remote1. Remember, that was a user we created that we gave dial-in access. I need to specify a password. That was the password of the user account we created. And finally, the domain, Battlestars. And also, I want it to remember the password, so I'll tick that option. I'm going to click Connect. It'll go through the process of authentication, verifying username and password. By default, it's set to automatic. It's just going to look for the first available connection. SSTP, PPTP, L2TP. Okay, and now I'm connected. So I can click Close now that I'm connected. And when I do that, notice if I go here, my connection actually shows up. And here it's also VPN to Galactica. And if I were to click on this, I could get details of my connection. So let's look at some details here. Remember that we said that 4 IP addresses were being utilized? There's 2 external and 2 internal. And the internal address is here. And that's 200.100.124. And that's the endpoints inside the encrypted tunnel. The external IPs are here, which is my IP through my internet service provider, and then that's also the VPN server's external IP on the internet. In this case, 220.1.1.1. So 2 totally, completely different networks, but NAT is taking care of translating this network and this network. And so I'll be able to connect to file servers and print servers and desktop computers on just as if I were connected to my local area network. And I'm going to look at properties here for this connection, and if I would go through some of these, notice I could select specifically PPTP or L2TP if I wanted to. Networking, sharing, just several different properties there. And I'm going to go ahead and close this. And again, if I went to adapter settings, I could disconnect, I could get the status on a connection, once I disconnected, I could delete the connection. I have the same access on the client here under adapter settings as I would here. So let's take a look at what this looks like on the server now that we've seen what it looks like on the client. On the server, notice that I had to refresh it, but I have a remote access client connected now. And that's my user remote 1. And I can look at that user status and see what they're up to. And then I could also reset that user. I could disconnect that user. Notice if I go to ports here, I can change in this case the listing here if I click on this column, but the active connection is this one right here, this point-to-point tunneling protocol connection. This is the connection that remote 1 is connected over. And if I go down here, let's see what else is happening. Our relay agent is relaying packets from our scope of addresses. Internet Group Management Protocol is doing its thing. And network address translation is translating packets. So all of this is going on the server, while the client's connected. So let's hop back to the client, disconnect, and we'll create another connection. This time, we're going to specify layer 2 tunneling protocol so we can use IPSec for encryption. So with this connection here, I'm going to disconnect. And it's still available there under adapters, but I'm going to create a new one now. So set up a new connection or network. I'm going to choose this option, connect to workplace, choose this option. In this case, no, create a new connection. And I'm going to specify, use my internet connection, 220.1.1.1. There's my public IP on the internet, so to speak. VPN to, I like to get, that first one automatic was PPTP, but I want to do L2TP, so I'm going to, in parentheses, I'm going to specify L2TP. Next, and remote 1, and type in my password, remember the password, type in the domain name. And I'm going to authenticate, verifying username and password. By default, it's going to lease an IP and set up its connection a mini WAN port over PPTP. But I want to get it to specify L2TP. So I'm going to disconnect. I'm going to go to adapter settings. I'm going to right click, go to properties. I'm going to go to security, and I'm going to specify layer 2 tunneling protocol in IPSec. I'm going to click on OK. And now I'm going to reconnect.